This is the third question from the mock test. A box has a kinetic coefficient of 0.12 and a static of 0.35. And it's a 2.7 kilogram box, right? And the first question is what forces needed to start it moving and what forces needed to keep it moving. And those are going to be, the force of friction, the formula we've got is that it's mu times the normal force. And this always becomes mu times m times g because the weight, the mg, is your normal force if it's just a level surface. And we're not going to go beyond that, right? So for the static one, to start it moving, right, is, or you can just always remember, right, the larger force is always the one to start it moving, whether you forget what static and kinetic mean, right? I'm going to use the bigger number, so I'm going to go 0.35 times 2.7 times 9.81. 9.8 is good enough, right? So 0.35 times 2.7 times 9.8. And I'm getting 9.261. And we still have sound. All right. Newtons. And that's the force, that's the maximum force you can have before it starts to move. Yeah?
So static is always bigger.
Static will always be bigger. I don't see how it could be smaller than to keep it going, right?
Yeah.
I think it's either you couldn't detect it or it has to be, yeah.
So it's the static times
Yeah, you just use the static coefficient, so the mu is 0.35 times mass times g. Yeah. And that's to start it going. I feel like I'm not answering your question. Oh, it's just this. Mu mg. Yeah. And then the kinetic, to keep it going, right? I just use the kinetic, so I use the 0.12 times. In fact, if you're really lazy, you can just take this entry you've got and change the 0.35 to a 0.12. And you get 3.1752 newtons. Crazy, huh? So I think that's answer A, is like, what is that? B says, what force would be necessary to accelerate the box once it's moving at 5.2 meters per second in the direction it's moving? It's like all these things, right? So there's B. Here's the box. Let's have it slide to the right. And we've got some force this way, right? And we want to accelerate it in the direction it's moving at 5.2 meters per second squared, right? Yeah, that's it, right? Why can't I just say that it's 2.7 times 5.2? Why can't I just say F equals ma and there we go? Because people do this on the test and it makes me so sad. Is that force the only force acting on it?
No.
Yeah, there's still a friction force, and then the question is, which one is it? Is it the one that you use only to tell whether it starts moving, or is it the one that you use when it's sliding? The sliding one, right? Never ever use this one in like an F equals ma equation because it's never moving when that one's relevant, right? And it has to be moving for you to find the acceleration. Okay, so so we can set this thing up. We know that the force acting this way is going to be the kinetic friction. So we know that there's 3.1752 newtons acting this way. Unknown force, we'll pretend we don't know it's to the right even though it has to be, right? And we'll say force minus 3.1752. Those are all the forces in the horizontal direction, right? And that equals 2.7 times positive 5.2, right? So we got to know all those things, right? Which way every force is, which way the acceleration is, and then we can solve this. F is going to be, I'm just going to take this and add that to it. So that plus 2.7 times 5.2. And I get 17.2152 newtons. So just don't forget. I mean, I have you do that on the test. Calculate this force, and then I say, well, what force, right? And then everybody forgets to put that in there and take it away. That's so sad. Isn't that sad? It's your only chance to show me that you could do it. Okay. And then it says, what is the acceleration of the box if it's moving to the right and there is a force of 2.6 newtons to the right? So here's this box sliding along. You need to compartmentalize, right? Here's the box. It's sliding to the right. There's a measly force of 2.6 newtons to the right, 2.7 kilograms. Okay. And then, of course, is that enough to keep it going even at a constant speed? No, you need 3.1752 newtons to keep it going at a constant speed, right? So what's this box going to do? It's not making enough money to pay its employees. Yeah, it's going to go out of business, right? Okay, it's going to slow down and stop. So the 2.6 Newton force is not the only force acting. What other force is acting? Yeah, there we go. Friction force is acting this way. I'm going to draw a little longer. So 3.1752, the same kinetic force that was acting here is acting there. That's just given in the problem. It says if there was a, in part C, right, a 2.6 Newton force. Right, so this thing's going to be slowing down. We should get a negative acceleration. How can it keep moving to the right if there's more force to the left? Why does it do that? What is that tendency of all objects called? There we go, yeah. It just keeps going because of inertia. It's going to slide farther than it would if we weren't towing it along at least a little bit, right? With just the friction, it would stop pretty quickly, but with this force, it's going to go a little farther, right? So I can say, I'm going to go 2.6 minus 3.1752 equals 2.7 times an unknown acceleration. So 2.6 minus 3.1752 divided by, hold on here, you wiseacre. And I'm getting A is negative 0.213037 meters per second squared. So it's slowing down. Does that make sense that it slows down? That's a weird thing. I think in the test that this force is a little more honest and, you know, American and apple pie, and I think it's bigger than the friction force, so it does actually accelerate that way. But it could be wrong. Because that's sort of a weird thing, right? It's slowing it down. Forces to the right, yet it's still bigger force to the left. Are we good on number 3? Do we have questions on that?